Hey guys, I hope you're all well. I'm sorry about the quarantine situation. I'm hoping I get a negative result. I don't feel the greatest in the world, but I'm not sure if it's actually COVID positive or if it's just anxiety for my daughter because she's been very sick. But either way, I wanted you to be safe. Also wanted you to have access to some actual instruction that you would see in class rather than just the PowerPoints and the videos. They're good. But here's just an extra layer, and if it helps you, great. Certainly will not be professional grade. I'm trying out new document camera recording so that I can write directly on the screen, work these problems. We'll start where I plan to begin anyway, discussing coterminal angles and angles that are considered reference angles. They're not exactly the same. Coterminal means that angles end in the same position. Reference refers to the angle at the x-axis, and we'll discuss both of those as we go along rather than isolating them. Here's one example that the book works through, and you could find this one worked through in your e-textbook on my math lab. They ask us to find an angle that's coterminal with 120 degrees. Several ways to do it. If they ask for a positive angle, that means that I'm going to need to go around the circle more than once. If they ask for a negative angle, then I could go around the circle backwards. I want to show you both methods now. So, coterminal with 120 degrees. From our earlier sketch, we remember that 120, this is 0, this is 90, this is 180, this is 270 for our basic angles all the way around. This is a positive 120, which means it will be measured up from the x-axis, and 120 degrees lies in the second quadrant in between 90 and 180. Exactly where it is, you could use a reference of 180. 120 is 60 less than 180, so the 120 would be approximately in this position. This is our first angle, 120 degrees. If I want a positive coterminal angle, I could go around the circle one more revolution and end up at the same position. It amounts to adding 360 degrees. So I could do 120 plus 360, and that should put me at 480 degrees for a positive angle that's coterminal. So let's just try that with our orange marker. If I want to end at the same place, I go all the way around. That puts me at 360, and then I need another 120 degrees to end up in that same position. So it is the 480 that is coterminal. There's also a way to do coterminal if you wanted to measure a negative angle that ends in the same position. Instead of measuring up and ending at this position in the second quadrant, you could measure down. Specifically, this is a positive one. If I want a negative coterminal, you would measure down, so that's negative 90. Halfway around would be negative 180. And then I know that that's another 60 degrees above that, so it would be at negative 240. So negative 240 is coterminal with positive 120. Now you heard me mention a couple of times that 60-degree reference with 180. It's how I know how far above or below the x-axis I am. I know that 120 is 60 degrees above 180. That makes my reference angle here be 60 degrees. Reference angle just means how far above the x-axis you are. And it helps you put things in the proper position. So there's one with degrees. We can do the exact same thing measuring radians. So let's find coterminal with 2 pi over 3. You could use your unit circle, or we can go backward. Coterminal, it's a positive coterminal angle. I need 2 pi over 3. Remember, 1 pi over 3 is here. That makes this one be 2 pi over 3, and I'm in the right position, but I'm going to continue and label them. This is 3 pi over 3, which reduces just to be pi. This one would be 4 pi over 3. This one would be 5 pi over 3, and this one is 6 pi over 3, which is the same thing as 2 pi. So we divided it into pi over 3 sections. How many did I need for this first angle? They asked for 2 pi over 3. That means this is the first angle that I'm dealing with, the 2 pi over 3. If I want a positive angle coterminal, I can go around the circle more than one time. I can take 2 pi over 3 and add 2 pi. You can do it with a common denominator, you can use your calculator, or you can count the way around, whatever works for you. If I went all the way around, I know that this is 6 pi over 3, then one more would be 7 pi over 3, and then one more would be 8 pi over 3. So this is coterminal with 8 pi over 3. You could also measure in the negative direction. If I'm looking for a negative angle coterminal with 2 pi over 3, instead of measuring up, you would just measure down. So this will be negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3 puts you in the same position. So negative 4 pi over 3 is coterminal. Let me slide that up for you. Is coterminal with 2 pi over 3. I didn't mention the reference angle for that one, but I need to, so let me go back with the reference angle. The reference angle for this would be the angle made here with the x-axis. How far above the x-axis? 2 pi over 3 is 1 pi over 3 unit above the x-axis, so the reference angle is pi over 3. Hope that helps for reference angles and with coterminal angles.